Hello, students. So, our topic of discussion for today is three-phase AC circuits or three-phase system. In electrical engineering, we mainly have two types of system basically single-phase and three-phase system. But it can be two-phase also. Here, two-phase AC system. So in this two-phase system, what will be the expression for voltage? So V1 will be equal to Vm sine omega t and V2 will be equal to Vm sine omega t minus 90 degree. This was the expression for single phase AC circuits and both voltage and current are in same phase. That means the circuit is resistive. Now for two phase AC system, there will be two voltage. One voltage will be V equal to Vm sin omega t and second will have the phase difference of 90 degree with respect to V1. So if this is your V1, then V2 will be 90 degree like this. Clear? So it will be the concept of two phase system. And in case of three phase system, voltage will be like V1 equal to Vm sine omega t, V2 will be equal to Vm sine omega t minus 120 degree and V3 will be equal to Vm sine omega t minus 240 degree. Here you can write also or Vm sine omega t plus 120 degree. So if I will draw the phasor diagram, suppose this is your V1, then this will be your V2 and this will be your V3. So with respect to V3, it is 240. With respect to V1, this V2 is 120 degree. And again, if I will go in the clockwise direction, then it will be equal to plus 120 degree. Clear? So this is what is the concept of three phase, single phase and two phase system. How we can generate three phase? As in my previous lecture, we have discussed that a single phase AC can be generated by using a coil rotated between two magnetic poles. The circuit diagram was like this. If we are having two magnetic poles and we have a coil, by rotating this coil between this N and S pole, we can get the single phase AC supply. Now, for two phase system, what we will do? We will rotate two coils at the place of one coil. We will rotate two coils. This will be the concept. We will rotate two coils and we will get two voltages having a phase displacement of 90 degrees. Suppose this one is A1, A2 coil and this one is your B1, B2, A coil and B coil. Again for three phase, we are having N and S pole and we will have three coils now. A1, A2, B1, B2, C1, C2. So in this manner, when these three coils will rotate, the phase displacement of 120 degree will generate between the voltage across each coil. Clear? Here these are N pole and S pole. So this is the concept that how three phase AC voltage can be generated. Now what will be the reason that we go for three phase system as compared to single phase system? There may be some reasons. So let us discuss those reasons. that why three phase system is used as compared to single phase system. So first one is three phase power. Three phase power has constant magnitude as compared to single phase power, because in single phase what will happen, in single phase in each cycle current or voltage will get 0 two times. Clear? So we can't get a constant magnitude. And what is the scenario of three phase system? In three phase system, let me draw. This is your R phase. After 120 the Y phase will start. This is your Y phase, and after 120 of this the this is your R, Y and B three phase system. Here, so here in three phase system we can get constant magnitude of power. Second point can be in case of three phase, for same amount of power transmission less copper is required as compared to single phase system. Clear? Next one can be the three phase machines. The three phase machines like motor, transformer, etc. are cheaper as compared to single phase, and small in size, also construction of three phase motors or transformers is simpler as compared to single phase system. Here, voltage regulation is better in three phase system as compared to single phase system. Clear? So these are some reasons for which we have chosen the three phase system. Now question may arise that why we are having a phase displacement of 120 degree only. We can have the another phase difference between three phases But why we are using 120 degree? First, the first reason may be like we are having a total 360-degree rotation. So 360 can be divided in three part, and one part will be 120-degree. And the second reason may be because with a phase displacement of 120 degree, the system will remain balanced. We can find this situation like, let me write the equations, and then we will find the total voltage. V1 equal to Vm sin omega t, V2 equal to Vm sin omega t minus 120 degree, and V3 is equal to Vm sin omega t minus 240 degree. Now let us solve this problem. So resultant will be equal to V1 plus V2 plus V3. Okay, now V1 is Vm sin omega t plus V2 is Vm sin omega t minus 120 degree, and V3 is Vm sin omega t minus 240 degree. Clear? Now let us take Vm sin omega t plus sin omega t minus 120 degree plus sin omega t minus 240 degree. Clear? So at the place of these two terms, what we can write, Vm sin omega t plus 2 sin a sin b. We can write here 2 sin a cos b. Then 2 sin omega t minus 180 degree cos 60 degree at the place of these two terms. Sin c plus sin d, 2 sin c plus d by 2 cos c minus d by 2. We can write like this. Clear? The formula will be what? Sin c plus sin d. So it will become 2 sin c plus d upon 2 cos c minus d upon 2. So this formula we have used here for the calculation. So cos 60 will be equal to 1 by 2. So Vm sin omega t plus 2 sin omega t minus 180 degree cos 60 is equal to 1 by 2. 1 by 2 and 1 by 2 cancel out. Vm sin omega t plus sin omega t minus 180 degree. So let me take minus outside. So it will become sin omega t minus sin 180 degree minus omega t. So 180 degree minus omega t is in second quadrant, so sign will be positive, and 180 is not changing line. It will be sin omega t only. So here Vm is at the outside. So both will get cancelled out, and the resultant will be equal to 0. Therefore, we have choose the phase difference of 120 degree between the three phases, that at any instant the resultant will be equal to 0. Clear? So you can also find this concept using polar form. Let me show you the concept, how you can use the concept of polar form. V1 is equal to Vm sin omega t. So here the angle will be equal to 0 degree. Second is Vm sin omega t minus 120 degree. So it will be equal to Vm angle minus 120 degree. V3 will be equal to Vm sin omega t minus 240 degree. So it will be equal to Vm angle minus 240 degree. Clear? Let us change this in terms of rectangular form, because we have to add all these three. So for addition and subtraction, what will we be use? We will use rectangular form. So first is V1 is equal to Vm angle 0 degree. So it will be equal to Vm cos 0 degree plus J sin 0 degree. Sin 0 degree will be equal to 0. So it will be equal to Vm plus J 0. V2 is equal to what? Vm angle minus 120 degree. So it will be equal to Vm cos 120 degree minus J sin 120 degree. Then on solving, you will get Vm in bracket minus 0.5 minus J 0.866. Clear? V3 is equal to Vm angle minus 240 degree. So Vm cos 240 minus J sin 240 degree. So it will be equal to Vm minus 0.5 plus J 0.866. Now when you will add V resultant equal to V1 plus V2 plus V3. So when you will add, what is V1? Vm plus J 0 plus minus 0.5 Vm minus J 0.866 Vm plus minus 0.5 Vm plus J 0.866 Vm. So here you can see this 0.5 Vm and 0.5 Vm, it will be equal to minus 1 Vm. So this minus 1 Vm will get cancelled out with this Vm. Now these two terms are positive and negative and same. So these two terms will get cancelled out. So overall V resultant will be equal to 0. So we have calculate the resultant voltage by polar form and by this method also. So here we can say that the reason for selecting 120 degree phase displacement between the three phases is because the system will remain balanced at each and every instant. Therefore we have chosen the phase angle between three phases is 120 degree. Now this three phase system have two types of connection, star connection and delta connection. We will discuss this star and delta connection later on in the next lecture. Okay, thank you so much.